going on? Tech Ed Online with Mr. White. So, our next project we're going to do is we are going to make a campfire grill. So, this is directed to my metals class, but I'm going to have the 8th grade and 6th grade sit on this because it's a cool project, and as they advance into high school and that, this would be good to see what kind of work we do in metals class. So what I'm going to do first is I have you here in my office on my computer so that you can see I'm going to start doing some designing, kind of foreseeing a few things, figuring out the dimensions, how the shape's going to look. I'll do that here. That way I can generate some drawings, and then we'll be able to take those over to the lab, and then we'll start building it. So you get to see how that's done. My designing software, I'm going to use a CAD software, computer-aided design, that's what it's called. I'm using SolidWorks, and that's pretty much the one that we use here at Williams Bay. There's all kinds of them. I'm not going to get into nuts and bolts and different ones there. When I do show you this, I'm not going to show you how to use the different parts of SolidWorks. It's very time-consuming, and there's no point in doing that right now when you don't have your own SolidWorks to kind of follow along with like you would here in class. So you can kind of see how I go and how quickly I move along throughout the project or throughout the SolidWorks part of it. I'm going to be creating the top, the legs for it on SolidWorks. I'm not going to be cutting the little grill marks for the campfire grill because I'm going to be cutting those to fit anyways when we go into the lab. So really their size right now doesn't matter, but the overall shape and design I want to do here. So moving to SolidWorks, we have the main SolidWorks screen. I went to new and I selected part, and I was able to get to this screen here. So now that I'm in sketch mode, or I will be here shortly, I'm going to create a circle. I'm going to start off by creating the top portion of our grill. So as I go here, just follow along. You'll see me click a lot and do a lot of different things. I'm going to draw out a circle, then I'm going to dimension my circle because right now it's just whatever. I've already made the decision earlier what size I wanted this to be, and I went with 11 3/4 or 11.75 inches. Okay. Now that's going to change the size of my circle. I also am going to put legs around the circle, and to help me within this software program, I'm going to create construction lines. I'm not sure when I go to assemble my parts in here if those construction lines are going to show up, but I'm going to do it anyways because they're just lines to give you points of reference. They actually don't hold any kind of shape or value in the overall design of my product. So I'm going to go in here and create a series of quadrants actually so that it gives me a good sense of where my legs should be going. Go here, right here. Try that again. One more. We should be good. Okay. All right, so there we have that. This is my 2D version. If we were looking straight down on top of our grill, this is kind of what it would look like. There would be bars going across here, but again, I'm not going to be putting those in for this drawing. I totally could. Here, I'll just put a couple just for kicks here. I'll put one right here. And we'll put another one here. I'm not going to make it crazy. And what I could do is smart dimension the distance here, and I want these lines to be, how thick should grills should be? About 3/4 of an inch apart. Let's make it 3/4 of an inch apart. All right, and then I'll do the same for this one. All right, and then I'm just going to go down the line. Oop, 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 oop. There we go. Now there are a lot of quicker ways to do this. I can make half of this and then use the mirror function to get it to reach across, but I'm not going to do that right now. I'm just going to zip out these lines. My screen went black, but that's okay. I put the bars across. Like I said, I wouldn't, but I changed my mind. Went 3/4 of an inch all the way across with some lines, and then I ended up with something a little less than 3/4 on the end. That's okay. So I'm going to be done with this part. However, this is just 2D, and I want to make it 3D. So I'm going to exit the sketch real quick right here, and then I'm going to give it some thickness. How we do that is we go to features and we extrude the shape. So as I'm here, we have everything highlighted, which is fine. I'm actually going to give it a dimension of 3/4 of an inch. Let me select all these here. So they all go to 3/4 of an inch. I believe my metal that we'll be using is 3/4 of an inch, but I'm not going to change its thickness or width, so it'll give me a good representation. So there's that. Check that off, and then we're left with basically a grill top. Nice. I don't see my construction lines on here, so that's kind of irritating. Hopefully I'll be able to draw some construction lines later so that I can put my legs on in the right spot in this digital part. So and then we know how to make some legs. I'm going to have 4 legs on here, but what's nice is they're all going to be the same. So all I got to do is make one part, because when I put it together, it's just a matter of copy and pasting. So this gets a little bit different how I'm going to do this, but just follow along and you'll see. messed around. I brought in some construction lines to tell where I needed to put my legs. And now what I'm dealing with is my grill. It's pretty much put together on how I'm going to do it. Now in SolidWorks, it makes it really difficult. But when I build it, it'll be a lot easier than SolidWorks in my opinion. But otherwise, I'll probably add a handle in here or something on a set of these two legs, and maybe I'll put a couple of them or all four of them and just attach a handle. It'll look better and it won't look so goofy. But essentially what I was doing is I wanted to have this to create a drawing. So what I'll do is I'll make a drawing from this assembly. We want this. Okay. Here we go. So what I'll do is I'm going to bring in some different views. This is called an orthographic drawing. A lot of you should be familiar with this, but basically it's a 2D drawing that gives you different angles and perspectives. And then this is third one up here, fourth one rather, is an isometric drawing, which I don't like how this is orientated, so I'm going to rotate that. It shouldn't be too hard to do. Actually, can we find the rotation somewhere in here? All right, we'll just leave it at that. So here's my grill. All right, now with this drawing here, I'll be able to add in some dimensions, and it's the same way as if we added smart dimensions. I'll be able to click on wherever I want it to measure from, like this top part all the way down to this bottom part, pull it out. So I got 13.46. I wanted it to be, oh, looks like it's not pulling from the actual bottom. I wanted it to be 14 inches. So let's try this again. Go to the bottom here. There, 13.5, so pretty close. Knowing the diameter is a pretty important thing, so 11.95. All right. It's nice that I can come in over here and override these values. This diameter is supposed to be 11.75. See, and the value changed there. I wanted this to be 14 inches, so I'll override what it's telling me. 14 inches. There's always a way around it here in SolidWorks. And then my legs, I'm pretty much going to bend them to fit and make sure they're all bent the same. And that should be good. I guess I'll get my overall width too. I guess it should. All right, everyone. So I have my plans here for my grill. I'm going to make it. I'm calling it the Campfire grill. I didn't really go into depth with SolidWorks. I had some trouble, as you can see. It's just one of those things with SolidWorks. Never built it before, so I was kind of learning about this circle, and mating these parts made it kind of difficult. But I was able to figure it out to get my shape and make it symmetrical on what I wanted to do, and all that. So I get the general idea. There are not a lot of difficult parts on here, so the SolidWorks, yes, it helps. I just wanted to give you an example of pretty much how we do that. But another example, you see this giant middle school trophy case, and this is where SolidWorks plays a nice hand in that. And I'll be going over this project eventually sometime with all this online stuff. But if you look, here I have, you can add skins to it, and then I have it broken down in different assemblies, giving you all these little nooks and crannies, squares,
I have it all defined. Here's the casing, here's the face frame, and it just keeps going. And then every page is a part that needs to be built for this. It's a little more intricate, it has a lot more parts for this grill. It doesn't really, but that would take a very long time to put in one of these videos, so I won't do that to you because I know that that SolidWorks part was probably a little stale for you. But so here's the deal. What I'm gonna do is I'm gonna create this grill, and you're gonna watch me create it. So pretty much what I'm gonna start off with is the main part, the grill. The main part on that is creating a circle out of metal, and then we're gonna weld those together. We'll create all the crossbars, which is gonna be a lot of cutting, a lot of welding, and then I'm gonna create the feet for it, which actually is probably gonna be the easier part of the project. So, there we go. Let's go select some material. All right, here I have a lot of metal material to choose from. Obviously, I'm not going to use these giant 50-foot, well, it's 50 feet worth of metal pipe, galvanized. Don't really want to work with galvanized stuff. It's toxic if you weld it, so I don't want to mess around with that stuff right there. But I do have a lot of this mild steel strips. Okay, some are thinner than the others, but I have a lot of this stuff right here. And this actually, when I was looking at it, I wanted 3/4 of an inch. I'm gonna take this caliper here and try to figure out. Alright. And that's pretty close to 3/4. It's a little bit more. It's about 20 thousandths bigger than 3/4. And I'm not getting an accurate measurement with the camera here. But this is my material. It's a little thin, but it looks like grill material to me. So we're gonna bend up this stuff. We're gonna make the legs out of this. We're gonna make the grill piece out of this. So what this is 3/4 inch, 22 gauge, or I'm sorry, 16 gauge mild steel. So it's easy to work with. I'll have to treat it and rub it down in order for it to be used as a grill. You don't just want to use anything as a grill in case there's hazardous chemicals on it. But pretty much I pulled some aside. I have some right here, and we're gonna make our circle. Here we go. All right, so I have some material here. I gotta find out how long do I need, or how much material do I need to create this circle. Well, one thing is I know that I want my circle to be a diameter of 11 inches and 3/4. And I lost my tape measure. I'm gonna go grab my tape measure. All right, got my tape measure. Usually you don't use this for metals, but I'm just trying to get a rough estimate of how much we need. I'm actually gonna cut the metal longer than what you'd actually need. So I found this weight here. It's 25 pounds, and I'm gonna use this as kind of my template to create my circle. What's nice about it, it's 11 3/4. So I'll be able to wrap, and I'm gonna use a hammer, and I'm gonna bend this metal all the way around it to create a nice perfect circle to shape it. So this is a part of metallurgy, is shaping metal, bending it to get a desired design or shape. So, but I need to know its circumference. I know its diameter, that's helpful, but what's its circumference? Math. I gotta think way back. Math. Oh, I know. The circumference is equal to 2 times pi times the radius. I knew I'd remember that. So, all right. I'm gonna use a calculator to figure that out, but if I take this and I take the radius, which would be 11.75 divided by 2, that would give me 5.875, which is 5 7/8. So I would take that, I would multiply that by 2, and then I would multiply that by pi, I love pi, and that gives me a circumference of 36 inches, 0.9, 36.9. So let me write that down, 36.9. I'm gonna test that out. I'm actually gonna tape my flexible tape here, and it doesn't like to bend all around things, just one bend, so it might break. It has some points of breaking around here, but I just wanna see how close I am and show you that math works. I said 36.9, I'm right at 37 inches, so that's pretty cool. I don't have to break my tape measure to figure it out and get a rough estimate, because that's not an accurate way or precise way of measuring. Math is. So 36.9, great. I need at least 36.9, I'm gonna round that up, 37 inches of material in order to create this circle. So, got plenty of stuff here. So let me readjust, and you'll see me cut this up. All right, so I made a mark at 36.9, 37 on my metal here. And what I'm gonna do is I'm gonna use this scribe, which is what you use on metal instead of pencil, because pencil doesn't show up. And then I'm gonna use this cute little square. Yes, it's not a square, but it's part of a square, and it has a 90-degree angle on it. Just to scribe, the method's called scribing. I'm gonna scratch a little mark on there. And then that'll help me see where I need to cut this thing. There we go. So let's take this over to the bandsaw, and we're gonna cut it. All right, this is our horizontal bandsaw. It's an awesome machine. It's got a really thick blade on it. Yeah, it's like bandsaws, where it has two wheels and a big band saw blade on it, but this is horizontal. And this is not like your vertical bandsaws where you can cut curves and angles and different things. This here only cuts kind of like a miter saw. It can only cross-cut things or cut them straight on. There's no turning around or creating curves. I can change the angle where I can cut what's called a miter cut, but in this case I just need a nice square cut, so I'm going to use that for this. So I'm going to load it up in here, get my mark close. Here's a little clamp that has a cam on it. I'm not going to clamp it yet. And then there's a bleed valve to help me lower my blade. Let me get it super close to my material, line it up with my line. I can turn it on. Won't turn on. Oh, the E-stop is pressed. Now it's running, and now, make sure this is connected. I can go ahead and open up the bleed valve and get it to cut. I like to keep my hand over here to kind of control it, another level of controlling it. So it's coming through the metal right now, you can't see. There it is. I can stop it here. Should stop on its own. Didn't right there, but there we go. I have my piece. Alright, so now that I have my piece here, double check, make sure I grabbed the wrong one. Now I need to shape this into a circle. So, like I mentioned before, I'm going to use this as a gauge or a kind of template, I'll call it a gauge, to shape it. So this is a tool. I'm using this as a tool. Yeah, it's a weight, but it's a tool that I'm using to get my project done. So hint, hint. Also going to use a vise. A vise is a great tool to have to help you hold things. It holds things a lot better than you can. So, or I. Make sure it's in there nice and tight. And I'm going to use this maul could use a ball peen hammer, any type of hammer, but this is nice and heavy, and I'm just going to bang this around my shape here.
Who's got the time to think? I got no time to think, 'cause I need somebody to love. Yeah, baby, I love you so, but you can't love me more. Why don't you hold me closer, and I'll give you more. Yeah!
Hi, Mr. Dunlap.
Oh, dude, sorry.
No, that's all right. All right, Mr. Dunlap came in and say hi, and then science teachers just came and left. We did a Lichtenberg test, or you might have saw before you left. I was showing them how to do that, but so got a little sidetracked. But I was able to bend this enough. What I'm gonna do is I'm able to get this pretty close to where I need it to create my weld. Once it's welded, then I'm going to take a blowtorch. I'm going to heat all this up, because what happens is when I put this together, there's a lot of tension there. It wants to open back up and return back to its shape. So what happens when you heat it up is the atomic structure of your metal realigns, and then it'll think that this is its shape it should be in. So there's a little more to it than that, but kind of in a nutshell, that's what it is. So I'm gonna get this together. I'm gonna have a clamp help me out, hold it, and I'm gonna weld it. I think it'll be good. So what I got going on here, took my weight off and put a clamp where the seam's gonna be, and then I'm just trying to take out any little imperfections here. I have two little humps. Just made it easier to bring it down so I can look down at what's going on. I want to be careful because this might pop off and then the thing's gonna pop open on me, but I got a clamp pretty tight, so it should be good, but you never know. So I'll set this a little bit and just kind of make my adjustments. I have a pretty good circle here for what I created in this hoop. So now I'm ready. Now I'm ready for welding. All right, I'll be over here a lot for this this project. Mainly, this is our welding booths here. If you're not familiar with, but I have 3 different types of welders. The one I'm going to be using for this project is called a MIG welder, or a GMAW, some people call it. It's gas shielded metal arc welding. So I'm going to use that. This one's nice because it self feeds a wire out, a filler rod, and the electrode that you need, and it's really nice for tack welding. And it's basically what I'm going to do with this joint is I'm going to tack weld my hoop right here so that I can get rid of the vise. I don't want to weld the vise grips. That way when I remove it, it'll stay together, and then I can finish a weld, and I want to weld all the way around that joint to make it solid. So it's nice here. I can put this here, holds it up for me. When I turn on the machine, I will use this curtain to get out of the way. I need to get dressed up here first, but I'm going to do that, and then I'm going to turn on the machine. I got to turn on gas. It's an inert gas, so it's not flammable. And then I'm going to turn on the exhaust system, because when you turn metal into molten metal instantly, there's some fumes that come off, and it's toxic. You don't want to be smelling that. So we have a really good ventilation system here. It sucks it right up these tubes, and away it goes. So yeah, I'm gonna get dressed up here. So literally, give me 1 second. All right. So I'm all ready to go. Like I said, with the molten metal, it can spray out, or it can go in other places besides the weld. So you gotta have leather. Leather does the best to, it's not gonna melt through like polyester would. So this is safe. I got my gloves on. These are nice welding gloves. They're really thick and insulated because this stuff gets super hot You don't want to be touching anything. So in the shop, when you wear gloves, you're usually on the, well, you're on the metal side of things. You don't wear gloves on the wood side of things. But keep using my safety glasses on. But I also have a welding shield that has a level 10 shade over it. Actually, this one is a self-adjusting one, and I can change it, the settings on here. So I want to double check that it is on number 10. And that way it's ready to go. So I'm gonna turn everything on. It's gonna get loud. You're not gonna be able to hear me. I'm gonna move the sheet across. You'll see a light, a flash. I'll be okay, and I'll move it across, and then we'll take a look at my weld. So here we go. On goes the gas. On goes the exhaust. On goes the machine. So hopefully that didn't blind you. I forgot to cover this, so we'll see how that goes. I don't know if it can't hurt the lens, I don't think, but probably be fine. Hopefully my body was in the way and you didn't see that. But anyways, I have a tack weld. Nothing too pretty, just a big old blob right there. And what I'll be doing is I'm gonna finish the weld and then I'll grind that down so it looks like part of the band later. So now hopefully when I take this apart, it doesn't fall apart. Well, it passed the drop test. So I'm gonna finish that up before it opens up on me. That seems like a good weld. Not gonna be back here for a little while. I'm gonna shut off the gas. Always shut off the gas. The gas I'm using is 75% argon and 25% carbon dioxide. Just a bunch of non-flammable gas, certain type of gas combination that works well with this type of welding. So, anyways, have that here. I don't want to touch that end because it's super hot, so I'm gonna quench it. I got my hoop. There's tension here. I bent it a little bit so there wasn't so much of a rigid corner. Of course, I have my welding. Still a little warm. My welding marks here, but I'm gonna go grind it down a little bit. I don't want to destroy the weld or break it, so I'll probably leave a little bump there, but I just want to grind it out just to get rid of this huge hump that I have going on, and to use the bench pedestal grinders because I like using that. Great tool. So, all right, these are our bench pedestal grinders. It's on a pedestal, on a bench. Here's the grinder. I have a series of them. This middle one I use for sharpening tools, so we don't use that for grinding raw metal. The other one has a wire brush on it and a belt sander. This belt sander is only for metal, so not for wood. But then I have this grinder here that we use 90% of the time, and it has a coarser wheel here and a finer here. For the sake of this video, I'm just gonna use the fine side, but you always wanna make sure that there's no cracks going through the stone, which is what this is called, because it could explode. Because when it spins, this one goes, where is it at? RPMs, 3,450 RPMs. So that's rotations per minute. So it's spinning really fast, and if the stone explodes in your face, you better be well protected, or you better hope that that doesn't happen. So that's why we inspect it. It takes 2 seconds. It appears good to me. Always want to keep your guard down. If there's a guard, use it. I'm also going to wear a face shield. I'm going to wear my safety glasses. I'm going to wear gloves. So lots of layers of protection with this machine. Okay? Here we go. Alright, so I smoothed down that bump. You can see right where it shined down to. This does spin around a long time. They call it coasting. So I have a piece of metal I keep on hand here, and I use it as a brake, but I use it on the coarse side because I like the finishing side, the finer side. That's it. That's grinding. So as I was saying earlier, I wanted to heat this hoop up because this hoop is a little, there's tension here. It doesn't look like it. It looks like it's totally fine. But I know because I bent it from its original form that there's some stress, atomically speaking. So down to the atoms, they're being stretched and pulled, which metal can handle that, but I don't want it to always to be under that stress. It's not good for the longevity or the lifespan of my campfire grill. So I'm just gonna heat this up, heat it up to about 220 degrees plus, get it kind of reddish in color, and the atoms should align. It's not gonna be the most efficient way of doing this, but like a forge would be, but it'll still help relieve a lot of the stress. And a lot of the stress is on the opposite side of my joint and throughout all these arcs that are here. So I got a couple stones. I'm gonna use our oxyacetylene torch. A lot of you metals know about this already, but those of you who've never seen it or seen it, don't know what it is. I have oxyacetylene. So this is oxygen, okay? And this is acetylene right here. All right, both of these things are off. They should always be off. I have directions on how to turn it on, but there's actually a sequence. And this is probably one of the more dangerous machines in the metal side of things because it is flammable. The gas is very flammable, oxygen especially, but acetylene is too. So there's a sequence you have to follow when lighting these things up. I'll do the sequence. I'll talk about it, but I'm not going to get all deep into it unless you take metals. Take metals, we'll get into this kind of stuff. All right, so first thing what I want to do is I'm going to open up the oxygen. Okay, then I'm going to turn the acetylene a quarter turn. That's 15 minutes. That's it. Don't need to do much more than that. Again, we need gloves. On my torch handle, I have oxygen is green coming in, and acetylene is the red coming in, okay? On the torch, it's gonna be a little different. I'm gonna slightly turn the acetylene. I'm gonna light the acetylene, so then I'll have a flame going, and then I'll start to add the oxygen as I go. Okay. My sparker ready. Here we go. Settling's going. Now there's gas in the air. A little too much settling. Maybe a little less. I like to wait till I see a bunch of soot. I should have the exhaust going, but I'm not going to because I'm not going to be here doing this long, and it gets kind of loud. Now that I see that soot coming off, I'm going to start adding the oxygen. Open up this one. This is also a secondary oxygen valve. And you get it to a point to where you see these blue cones. I don't know if you can see it on the camera there, but there's these little blue cones on the end of your torch, and that's how you know it's good. I can also use this regulator here, this check valve, to add more oxygen, and then this actually can be used for cutting metal as well. And it does that. I don't really need to use that for what I'm doing here. I can if I want to like get it really hot really fast, but I'm not going to. I'm just going to go around my hoop here and heat it up. So now let's shut this off. I'm going to do the exact opposite of what I did before. Shut off my oxygen. Shut off my oxygen down here too. Now I can close off my acetylene. Everything's really hot, so careful. Now I'm going to shut off my acetylene here. I'm going to shut off my oxygen completely here. That's that. Now this thing is super hot, as you can see. Trying to burn through my gloves, so I'm gonna quench it real quick.